Okay, guys. So in the last class, we have taken up a demo on what certified ethical hacking course is about. We've learned basically what topics we'll be going through, what tools we'll be working on. Okay, and again, what is the course curriculum and what the structure of the course is about. And in today's class, we'll be going with the first topic, okay, which is networking fundamentals. So this is a very important prerequisite for cybersecurity. Understanding what networking is, what IP addresses are, what the categories of IP addresses are, okay, what is the range of IP addresses, and some important networking protocols. Okay. So let's get started without any further ado. So when you talk about networking fundamentals, there are three important definitions to know. What is networking? What are networks? And what are hosts? When you talk about networking, this is a practice of connecting information devices with each other. Okay, so in an organization, you can have all sorts of devices. You could have routers, you could have switches, you could have again client operating system, desktop machines, you could have servers, you could have printers, you could have cameras. Okay. So the concept of connecting all of these information devices with each other so that they can communicate with each other and share information with each other is called as networking. Okay. And that collective group or that one singular network of devices, okay, or the collection of those interconnected devices is called as a network. Okay, so an important point to note is when a device is in a network, it can communicate with all the other devices in the same network. Okay, so it's a collection of all interconnected devices that can share information with each other or communicate with each other. Okay, and then each individual device or each individual information system in that network is referred to as a host. Okay, so host refers to any device connected to a network that can transmit or receive data. Okay, as mentioned already, computers, printers, routers, mobile phones, IP cameras, smartwatches, okay, etc., etc. All of these are your, again, hosts connected in a singular network. Now, just like how we humans have our respective names to address and identify each other, these devices also have names, and those names are called as IP addresses. Okay, to define an IP address, each host on the network has a unique identifier. Okay, and that's known as an IP address, Internet Protocol Address. Okay, and these Internet Protocol addresses allow for communication to occur between the hosts. Okay. A brief history on them. These were invented by the US military again in the late 1950s or so. There were multiple experimental versions as well. IP version 1, IP version 2, IP version 3. They were just experimental. They didn't work out again properly. What successfully worked out was IPv4, Internet Protocol version 4. And we're still using IPv4 addresses even in today's world. Okay. So yeah, again, as mentioned, IP address is the identity assigned to every system, a unique identity. Okay, and with that identity itself, communication occurs between these devices. Okay, and your IPv4 address has a few important properties to it. Okay, so firstly, it's a 32-bit address. What I mean by 32-bit is that it contains 32 zeros and ones consecutively. Okay, a bit is the smallest data value a computer can hold. It can either store the information 0 or the information 1 in that place. Okay, and your IP address consists of 32 bits in it, 32 zeros and ones in it. Okay. And this entire 32-bit address is not one singular sequence. It's divided in four equal parts again of octets. So each of those four equal parts contains 8 bits in it. Okay, and each of that 8-bit portion is known as an octet. Okay, and each octet again is separated by a dot symbol. Okay, so this is what your typical IPv4 address would look like. You have 8 bits here, as you can see, 1100000008 characters, then a dot, then another 8 characters, then a dot, then another 8 characters, then a dot, and then another 8 characters there. Again, that is your entire 32-bit IPv4 address. Okay, so what you see here, this format of zeros and ones is also commonly known as the binary language. This is something that the computers easily understand. But we humans, what we regularly use are decimal numbers, numbers from 0 to 9. So now I'm going to show you how do you convert any binary number into a human readable decimal number. So this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number with all zeros is simply 0. And this number 00001010 is actually equal to 10. Okay, so I'm going to show you now how do you convert any binary number into its human readable decimal number format. Okay, any questions or doubts up to this point? Anyone? Karthik, Nipur, Sanjana, Sudhakar.
No, Shoaib.
No, sir.
Good morning, sir. Not as of now.
Hey, okay, perfect. Moving on. So let's talk about the conversion. So it's a very simple process. Let's take this number 10101010. Okay. So to convert a binary number to a decimal number, there are two steps involved. Step number one is you write down the values from 2 power 0 all the way up to 2 power 7 from right to left. So under the rightmost bit, you'll have 2 power 0, then 2 power 1, then 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and finally 2 power 7. Okay. If you ask me a question, why specifically 2 power everything? It's a binary number. There are only two possibilities, zeros or ones, hence 2 to the power everything. Okay. Now, once you have written down these values, you multiply the lower value with the top bit and you add it to the next one. So 2 power 0 into whatever bit is there on the top plus next one 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1. So whatever bit you have on the top, you multiply that with the lower value and you add it to the end. Okay, so let's write down these values first from 2 power 0 to 2 power 7. Anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is similarly 32, 2 power 6 is 64, and 2 power 7 is 128. Now that we have these values here, we can substitute them here and we can get the final answer. So 2 power 0 into 0. So 2 power 0 is 1. So 1 into 0. That's simply 0. Plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. Plus 2 power 2 into 0, again 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, again 0. 2 power 5 into 1, 32. 2 power 6 into 0, again 0. 2 power 7 into 1, 128. So now, since we have all these values in decimal numbers, we can add it up. 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. Something like high frequency, low frequency, high, low, high, low, high, low. So when that exact sequence of frequencies flows through a computer, it understands it as this number 170. Okay. I hope this is clear. Any questions or doubts in this conversion, guys? Sudhakar and Karthik, Nupur, Sanjana. If this is clear, guys, there are two other numbers here. What I want you to do is take a pen and a paper, if you have one beside you, and convert these numbers into the decimal values and give me the answers for those. So there's one number 01010101, example 1, and the example 2 is all ones. I've written down the values from 2 power 0 to 2 power 7. Take your time, no rush. Okay, so convert these values and give me the decimal answers. You can post the answer in the chat. Okay, so take your time, guys. I'm just gonna go 2 minutes away from the keyboard. Okay, and meanwhile, please try calculating this and give me the answer. Okay, first example 01010101, and the second example all ones. I hope the example from the previous slide is clear though. If that is clear, only then you can calculate this. Does anyone want me to explain the previous slide again? Karthik, Nupur, Sanjana, uh, and Darlis. I think that's Sudhakar.
No, I'm clear.
Okay, perfect. Let's wait for the answers then. Just give me 2 minutes, guys. I'll be back in the meantime. Okay. Hey guys, apologies about that. Had some background disturbance from my end, so I have to clear that up. And I've got some answers. One is 85 to 85 to 55. Okay, perfect answers everywhere. Okay, correct answers, guys. So the first one is 85, as you can see. Okay, and the second one is 255. Perfect job. Okay, now you might have a question. Why am I explaining all this? Okay, what is the necessity for the conversion? Okay, this conversion now allows us to understand the range of IP addresses. So if I have to get the first IP, all I have to do is put the minimum value everywhere in every bit, which is simply all zeros. And when I put all zeros, I get the first IP as 0.0.0.0 in decimal. And if I have to get the last IP, all I do is put all ones everywhere. Again, when I put all ones, you get the last IP as 255.255.255.255. Because all ones, as you've just calculated, is just 255. Okay. So no IPv4 address can go beyond this range of 255. Whatever IP addresses exist, they would always exist between the number 0 and 255 itself. Okay. And if we have to calculate how many IPs are there in total, each bit here has two possibilities. There's either a 0 or a 1. And there are 32 bits in total. So for every bit, since there are two possibilities, you multiply all those 32 possibilities again. So 2 into 2 into 2 into 2 into 2, 32 times. A simple permutation or combination formula. And that would give you the number 2 raised to the power of 32, which is approximately or closely equal to 4.3 billion IP addresses. So back then, when these IP addresses were invented in the late 1950s or so, they thought 4.3 billion IPs is a very large number. But fast forward to 2025, the population itself is around 9 billion people. Again, each person again could have on an average multiple devices, not just a singular device. Okay, so this 4.3 billion IP range would never have sufficed. Okay, if you assigned each IP individually to each system. Okay, so that is why these IP addresses are again divided in various categories. There's something called as classes, and then there's something called as public and private IPs. Okay. Now, before we dive into those categories, let's talk about the sequence of IPs. Now, we know this is the first IP, and we know this is the last IP. What about the IPs in between? How are the IPs progressing one after the other? Let's talk about that. Okay. I hope this concept is clear though, how we got the first IP and how we got the last IP. Okay. So important point to note, no matter what IP address you take in the IPv4 range, it will only range between the number 0 and 255. And you yourself have given me that reason, okay? Because when you calculate it with all ones, you only get the maximum value of 255, okay? So in an octet with 8 bits in it, the maximum number you can obtain is 255. You cannot go beyond that, okay? Moving on. So let's talk about the sequence. Okay, so we know the first IP is 0000, and the last IP is 255, 255, 255, 255. So what about the sequence in between? To understand the sequence again, there are two simple rules. Rule number one, always start incrementing from the rightmost octet. Okay, so what I mean by that is if you have the first IP as 0000, the rightmost octet always increments by 1. It increases by the value of 1. Okay, so the next IP would be 0001. Next IP 0002. Next IP 0003. Next IP 0004. Next IP 0005. Next IP 0006. This goes on all the way up to the value 000254 and then 000255. Now, after this, we cannot have a value like 000256. That's not possible in IP addresses, guys. Okay. So once you reach the maximum value in the rightmost octet, then comes the rule number 2. Okay. So once the rightmost octet reaches maximum value, then you move to the left octet. Okay. So this 255 resets back to 0. Okay. And now the left octet increments by 1. Okay. So then you have 0010. Okay. Now please note, don't directly jump to 0020. There's rule number 1. Always increment the rightmost octet. So after 10, you have 0011. Then 0012. Same cycle, 13,
Sir,
14,
one
15.
question.
Yeah, sure.
After this 0100, uh, second second number should be 0200. Oh no.
No, please note, as mentioned, it should always increment from the rightmost octet. Rule number one. So after 0010, okay, if you directly jump to 0020, that would be wrong. Okay, so this rightmost octet, the 0, increments by 1 after that. Okay, just like in the first sequence here, after 00, you had 01, 02, 03, 04. Similarly, 10, 11, 12, 13, 14. This goes up to 1255. Now, once this reaches to 255, then this 1 changes to 2, and then you have 20.
Sir, at
Is that clear?
one point of time, one value will change or
Yeah,
remain.
the rightmost value always.
Okay.
Right, exactly. At one point of time, only the rightmost value always changes. Okay. After the rightmost value reaches the maximum value, then the left value changes. Okay. To explain this in a much better way, I hope you remember in the olden days, I think even now, some devices, or not devices, some vehicles come with a odometer in the manual way. So there's something called odometers, which some people also know them as speedometers. Okay. So this is what an odometer looks like. Okay. In the older vehicles, you had this cycle. So in today, it's everything digital. If I go to the images, okay, you remember how this used to work? So if you see this number 099999. Okay. So same logic there as well. So if I open up a notepad file here, that's it. So the first value you would have is 0000, let's say. Okay. Then what would the next value be? After you've driven 1 kilometer, the next value would be 0001, right? So after you drive 2 kilometers, 0002. So rightmost value increments by 1. Okay, 0003, 0004. This goes on all the way up to the value 0009. Okay, so assume the 0009 is something like 000255. Okay, and this first value is something like 0.0.0.0. Okay, so what happens after 0009? After 9, you have 10 kilometers, 0010. Okay, which is something like 0.0.1.0. Okay, after 10, you don't directly go to 20, right? You have 0011, right? So which is something like 0.0.1.1. Okay, then 0012, 12 kilometers, then 13 kilometers, 14 kilometers, and then somewhere down the line, you would have 0019 and then 0020. Okay, so
Sir,
same
I
logic,
didn't
0012.
got it. The second octet is constant as 1.
Yeah, the second from the right. Yeah,
Yeah.
the second octet always stays constant because again, there's 10, 11, 12, 13, 19, and then you have 20. So therefore, 11, 12, 13, and then 0014. Okay. Again, somewhere down the line, you would have
0.
0.0.1.255. Okay,
Okay.
and then 0.0.2.0. Okay, so assume this 9 is the maximum value here, and here you have 255 as the maximum value. Okay,
Okay. And
so after
after this
1 9,
0.0.0.2.0, after that, what will be 0.0.2.1?
that's it, 21 kilometers. Same logic. Okay, so the same pattern repeats everywhere. So 00 to 09, 10 to 19, 20 to 29, same thing. 00 to 0255, 10 to 1255, 20 to 2255. Okay, as you can see, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255. The cycle keeps repeating again and again and again and again. And somewhere down the line, you would have 2550 to 255255. Now, this is something like 99 kilometers. Okay, so somewhere down the line, you would have something like 0090 to 0099. Okay, so the 0090 is like 0.0.255.0 and 0099 is 0.0.255.255. Now what comes after 99?
100.
100. So what would that be? 0.1.0.0. Okay, all rightmost octets cycle back to zeros and the left octet increases by 1.
Then now
Okay.
what next of this? After this 0.
Next one is 0, 1, 0, 1. 101 kilometers, which is 0.1.0.1. Okay, so the same cycle 0, 0, which started here, repeats up to 0255. Okay, so 0.1.00 goes up to 0.109, which is something like 0.1.0.255. Okay, and then you have 110 kilometers, okay, which is 0.1.1.0, which goes up to 119, 0.119, okay, which is something like 0.1.1.255. And then you have 120 kilometers, which is then 0.1.2.0. Okay, same pattern, 00 to 0255, 10 to 1255, 20 to 2255. So whatever pattern repeated here, 10 to 1255, 20 to 2255. Oh, sorry, I think I forgot to write that here. 0029, which goes up to 002255. Okay, like that, the same pattern repeats again from 0, 1, oh, sorry, 90 to 0199, which is something like 0.1.255.0 to 0.1.255.255. Okay. If you notice, that's the same pattern which we follow here. 100 to 1255255 over here. 200 to 2255255. Okay. So again, after 199, what comes next? Then you have 0, 200,
This
0200. Oh yeah, Looper, go ahead.
we should remember all of this.
No, you just need to understand the sequence of how the IPs are progressing. Okay, because in the upcoming sessions, when you form networks, you need to know how each address is being differentiated. Okay, which device is getting assigned what address, and after that, what comes. Okay. You don't need to remember the entire range. You just need to understand the sequence of how they are progressing one after the other. Okay, so if this seems a bit complex, you can just remember these two simple rules. Okay, the reason I showed you this whole thing is because it's the same logic as an odometer. Okay, in reality, where the limit stops at 9, in IP addresses, that 9 is replaced with 255. That's the only thing you have to understand. Okay, so again, as it's very simple logic. Okay, so always increment the rightmost octet, and when the rightmost octet increases or reaches the maximum number, then you reset it back to 0 and move to the left octet. Okay, that's the same logic that flows in this entire circle. Okay, 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, which goes on all the way up to 2550 to 255255. Once both these octets are full, this next 0 changes to 1, and you have 00 again. So the same pattern repeats: 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, and then 2550 to 255255. Okay, when these two octets are full, this 1 changes to 2. So if you see, there's a pattern here: 000 to 0255255, 100 to 1255255, then 200 to 2255255, 300 to 3255255. Okay, that's something like from 100 kilometers to 199 kilometers, 200 kilometers to 299 kilometers. Okay, 0 to 255 Okay, then 300 kilometers to 399 kilometers, which is like 0300 to 0399, which is like 03255. And somewhere down the line, you would have 0900 kilometers, okay, to 0999 kilometers, okay, which is something like 025500 to 0255 Okay. So what comes after that? After 999 kilometers, you have 1000 kilometers, which is 1000. Okay. So whatever pattern repeated all the way up to here, from 0000 to 0999, that same thing repeats from 1000 kilometers to 1999, okay, which is something like 1255255. Okay. Then same thing repeats from 2000 to 2999, okay, which is like 2000 to 2255. Same thing again repeats from 3000 to 3999. Okay, which is something like 3000 to 3255. And this goes all the way from 9000 to 9999. That's the maximum value, which is 255000 to 255. Okay, so you see that's the same pattern which I've written down here. 1000 to 12552552555. 2000 to 2255255255. So whatever pattern repeated from 0000 to 0255255255, this same entire pattern repeats from 1000 to 12552552555. 2000 to 2255255255. 3000 to 3255255255. 4000 to 4255255255. And finally, in the end, 255000 to 255 255, 255, 255. If you count each and every single IP individually, there would be a total of 4.3 billion IP addresses there. Okay, that's how you get that number. Okay, I know it seems a bit complex today, but again, I try to revise this, guys, if possible. Okay, this video is going to be uploaded on YouTube, so you can refer back there. Okay, the first 2-3 classes are free as demos, so they're being uploaded on YouTube, and then after that, you'll get this documentation and out directly from me. Okay, for the registered students. Okay, so I know seems a bit complex. I think we can stop over here for today, and in the next class we'll go a bit more in depth. Okay, what are public and private IPs? Okay, we'll talk about that. Then we'll talk about what are the classes. Okay, what is class A, B, C, D, and E? What are their specific ranges? What's the relevance of each class? Okay, what is class B? What is class C? What is class A? And then some important protocols. What is subnet mask? What is DHCP protocol? Okay, what is DNS protocol? We'll cover all that in the upcoming sessions. Okay, for now in today's class, what we have learned is what are IP addresses in the first place. Okay, what is networking? What are networks? What are hosts? Okay, what are IP addresses? What are the properties of IPv4 address? Okay, what are the range of IPv4 addresses? How do you convert a binary number to a decimal number? What's the first IP? What's the last IP? And what is the sequence of IPs? That's what we have covered for today. Okay, I know seems a bit complex, guys, but again, if you revise this one more time, a lot of things get cleared. Okay, but I hope again there's no confusions for now, up to this point at least. Okay, to understand this pattern, just understand how your odometer works in a vehicle. Okay, replace that 9 with 255. That's the only thing. Okay, is that clear, everyone? Any questions or doubts? Adarsh, Nupur, Sudhakar, Karthik, Sanjana, Ram. Hello.
Thank you so much, sir,
No,
for
Shoaib.
such a good explanation. Sir, just one last time, could you
Oh,
please go to that range? Actually, I'm just
range.
trying to
Okay.
do it myself. Yeah. Just want to
Yeah, sure.
ask something. Suppose we take 4.0.0.0.
Okay.
It
So
will
let's
go
say
up
we
to,
have,
uh,
yeah, so
yeah.
let's say you have something like 400 kilometers. Okay. That is simply 0.4.0.0. Okay. What happens
Yep.
after that? After 400 kilometers,
Mm,
you have 401 kilometer, which is 0.4.0.1. Then 402 kilometers, okay, which is 0.4.0.2. Okay, then you have 0.4.0.3. Then you have 0.4.0.4. This goes all the way up to 0.4.0.255. Okay, and then you have 0.4.1.0. Okay, so just look at the rightmost objects: 00 to
mm,
0255, 10 to 1255. So 0.4.1.255. Then 20, 0.4.2.0 to 0.4.2.255. Then 30, 0.4.3.0 to 0.4.3.255. This pattern repeats again and again and again. And somewhere down the line, you would have 0.4.255.0 to 0.4.255.255. Okay. And then you would have 0.5.0.0. Okay. So this is something like 0.499 kilometers. And then you have 0.500 kilometers. Okay.
Sir, in case of 4.0.0.0, what will
0,
be
0.
asked first? Sir, you just tell me once
Where?
4.0.0.0. What will be after
Oh,
that?
4000. Okay.
Yeah,
That's 4,000 kilometers. Okay. What
mm,
comes after 4,000 kilometers?
4,001.
4,001.
Hmm.
So that would be 4.0.0.0, which goes up to 4.0.0.1. Okay. Same thing like 1,000, if you
Then
notice over here.
4,002, it will come 4,002 after that. 4,002,
Yeah.
4,003.
Yeah. Yeah, that's it, which is like 4.0.0.2. Okay. Then you will have somewhere 4009, which is like 4.0.0.255. Okay. Same logic that we saw here in 0000, 0000, which goes up to 0000255. Then you have 101, which goes up to 1255, 20, which goes up to 2255. Okay. So same thing, 4000, 4001, 4002, 4009. Okay. Then 4010, which is 4010. Okay. Which goes up to 401255. Then 4020, then 402255, then 4030. Oh, sorry. Okay, which goes up to 403255. Okay, this pattern repeats again and again and again, and somewhere you have 402550 to 40255255. Okay. Okay, this is something like 4099 kilometers. What happens after 4099? 4100, which is 4100. Okay. And the pattern repeats again all the way. Okay. So I
Got
know it
it.
seems a
But
bit tough.
is it easy?
Yeah.
Totally understood.
Sorry.
Thank you.
You understood now? Okay.
Yeah, sir. Thank you. Thank you for explaining in an easy way. Thank you.
No worries, no worries. Guys. The voice is a bit husky today. I have a bit of a sore throat, but I hope the voice again was clear earlier at least. And yeah, I hope everyone understood this. Adarsh, Nupur,
Yeah.
Sudhakar, Karthik, Ram, Sanjana.
Yeah.
Excuse me. Yeah, Sudhakar, you were saying.
No, I'm good.
Sir, we need not to change from decimal to binary, right?
Not required, but if you want to know how to do so, I'll show that in the next class. Okay. The only reason I've shown you how to convert binary to decimal is so that you can understand the range, guys. Okay, what is the first IP? What is the last IP? Okay, why are you getting the number stuck at 255 and why it's not going beyond that? Okay, that's the only reason I wanted to show that conversion. Okay, but no worry, if you want, I'll show you how to convert a decimal number into binary as well in the upcoming session. Okay.
Sure.
So yeah, that's that. Tomorrow will be the next demo class, guys. We'll conclude all the other topics. We'll talk about, again, the classification. What are classes and IPs? We'll talk about the public and private IPs, and we'll talk about some important protocols as well. Okay. So yeah, that's that. Nothing further for the session today. We can exit here. We'll connect back tomorrow at the same time. Okay. So we'll start the class at around 7:35, just waiting for all the other students to join. We'll start sharp at 7:35. Apologies for the delay today. I didn't show this link. Okay. So I think there was an issue with the Cloudflare yesterday. Not Zoom wasn't working, ChatGPT wasn't working for some reason. But yeah, I think it's resolved today. Okay, so yeah, that's it. Nothing further. We can disconnect here. We'll connect back tomorrow at the same time. Have a good day, guys. Thanks for joining the session today.
Thank
Bye-bye.
you so much, sir. Thank you.
Thank you.
Thank you, guys. Bye-bye.
Bye.
Bye, guys. Take care.